All right, today we're going to start
Today we're going to start looking at logarithms. There is a relationship between a logarithmic equation and an exponential equation. So over here on the right you see y equals b to the x, so just a very basic exponential equation. Well, notice that the b here, this is what is the base of the exponential equation, and then of course the x is your exponent. Okay, now a logarithmic equation, this equation here to the left, you would say log base b of y is x, or is equal to x. Okay, so that's how you would read that. This little number down here is called a subscript, but that is your base of your logarithm. Okay, so if you notice, log base b of y equals x, if you rewrite that in exponential form, the base of your logarithm becomes the base of the exponential equation, and then what your logarithm is equal to becomes the exponent, and then it is equal to y. Okay, so the first thing we're going to practice is rewriting logarithmic equations into exponential equations. So this first one, log base 2 of 32 is 5. So the base of our logarithm here is 2, so when we go to rewrite that as an exponential, that's the base of our exponential. Your 5, okay, what your logarithm is equal to, that becomes your exponent, and then it would equal 32. Okay, so 2 to the 5th equals 32. So that is the same, that's an equivalent statement to the log base 2 of 32 is 5. Okay, example 2, again, find the base. So this is log base 10 of 1 equals 0. Okay, so the base of this logarithm is 10. And then when I go to rewrite this as an exponential, start with the base 10. What your log is equal to becomes your exponent, so it would be 10 to the 0 equals 1. Okay, number 3, now this one, it has 2 9s in it, but your base here, your base is this 9, remember your subscript, so to rewrite it as an exponential would be that base 9, your exponent is 1 equals 9. Okay, and then for number 4, log base of 1/5 of 25 equals -2. Well, your base here, 1/5, this becomes your exponent and equals 25. Okay, all right. So then what we're going to do is go the other direction. So if you have something written as an exponential equation, you can rewrite it as a logarithmic equation. So we're just going to do the same thing but in reverse. Okay, so this base, y equals 2 to the x. Okay, there's the base of my exponent. When you rewrite that, that becomes the base of your logarithm. So it's going to be log base 2 of y equals x. So remember that exponent came from the answer, I guess so to say, of your logarithm. So you're going to rewrite that similarly, log base 2 of y equals x. So it's going to be equal to that exponent. Okay, example 6, 8 equals 2 cubed. So same thing, your base from your exponential, that's going to become the base of your logarithm. So log base 2 of 8 equals 3. So again, that exponent is going to turn into the solution of that logarithm statement. Okay, then these next two, so 1/16 equals 2 to the -4th power. So again, my base happens to be 2. So this is going to be log base 2 of 1/16 equals -4. So my base and then that exponent, that becomes the solution to my logarithm. Okay, one more of these. So 7 to the 0 is 1. So 7 is the base of that exponential. So log base 7 of 1 equals 0. So again, that exponent, that becomes the solution of your logarithm. Okay, so what we just spent the last few minutes doing was just converting from logarithms to exponentials and then exponentials to logarithms. Okay, so you can convert back and forth. Kind of similar idea is I can change a fraction to a decimal, then I can change my decimal back to a fraction. Okay, so this piece of information here, okay, you're going to need to understand that concept and know that concept of how do I convert from one form to another. Okay, then this, evaluate the following logarithms. So we have a logarithmic equation here. We're going to solve it for x. So since logarithms can be rewritten as exponentials, we're going to rewrite it as an exponential equation and then see if we can solve it. So my base is 3, so log base 3 of 81 equals x. So this would be 3 to the x power equals 81. So now you're solving this. You're trying to figure out what exponent. So 3 to the 4th power would be 81. So x equals 4. 3 to the 4th is 81. Okay, similarly with number 10. So log base 1/4 of 256 is x. So rewrite this. So this would be 1/4 to the x power equals 256. So here, this one's going to be a little more difficult. You're going to want to do the reciprocal of that 1/4 and make it a 4, because if I can change that to a 4, then I know that 4 to the 4th is 256. Now you might not know that right off the top of your head, so you might have to kind of try some things. You know that 2 squared is 16. Hopefully by now you probably remember that 4 cubed is 64. So then 4 to the 4th, that gives you that 256. Okay, so we figured out an exponent of 4 there. But since I want to do the reciprocal, negative exponent, we'll do the reciprocal, so x actually is going to equal -4. So x to the -4th does the reciprocal and then takes it to the 4th power. Okay, 11 and 12 are the same as 9 and 10. The only thing that I didn't do here is I didn't write them as equal to x. Okay, so you might want to do that. Kind of helps you understand that connection between the exponential and the logarithm. So again, base 10. So 10 to the x power equals 1/1000th, and this would be x equals -3. So scientific notation, if you kind of think in scientific notation, move that decimal 3 places to the left, so 0.001 or 1/1000th. On number 12, we would have 64 to the x power is 2, so you're figuring out what x is. Okay, now you might think of this in the other direction. You know that x to the 5th is 32, or sorry, 2 to the 5th is 32. 2 to the 6th will be 64. Okay, so how could you use this to help you here? So 64 to what power equals 2? Well, to get rid of that exponent of 6, you would do the 6th root. Okay, so 64 to the 6th root is 2, or x would be 1/6 power. Okay, so those first couple may be fairly easy for you to kind of reason out and figure out what the value is. The last couple, a little bit harder. We could still do it, but got to think a little bit more, think about what rational exponents, so those become a little more difficult. Okay, so in the coming days, I'll show you another way that you can simplify those logarithms. But for today, we're just kind of working on this concept of shifting back and forth from exponential to logarithms. Okay, there are 2 logarithms that I want you to be aware of. Common log is log base 10. So that's this first statement here. So you'll notice log base 10 of x equals log of x. Okay, so you know that if I just say x, everybody understands we mean 1x. That's the same kind of concept here. If you just see log x and there's not a base specified, then the understanding is that you recognize that as a base 10. Okay, so if you just see log x, that means log base 10. Okay, on your calculator, you've got two logarithm buttons. One of them just says log, L-O-G. That's this one. That's the common log base 10. Okay, the other button that you have says ln x. ln x, this is the natural log of x, and it comes from the concept of log base e. Okay, we talked about e on Friday. If you remember, it's an irrational number. It's approximately equal to 2.7. Okay, but natural log means log base e. Okay, on your calculators, we'll just look at these couple of buttons. Okay, on your calculator, you can type in log of 8, which is about 0.903. Okay, so keep in mind what this is in relation. This log 8, okay, remember what we just talked about? Like if there's no base written there, that means log base 10. Okay, so this is the common log base 10. So if I want to think of this in terms of an exponential, this would be 10 to the 0.903 power equals 8. Okay, that's what that value is. And it makes sense, because if you think about 10 to the first is 10, so if I want to use a power of 10 to represent 8, it would need to be an exponent that's a little bit smaller than 1. Okay, so 10 to the 0.903. If you want to try that out on your calculator, you can. You can use your caret and just test that out. Okay, 14, natural log of 0.3. So if we go back, natural log, next to your 4, natural log of 3/10 is about negative 1.0204 approximately. Okay, so same concept here. So if we want to think of this in terms of exponents, then we would have e to the negative 1.204 power, and that's about 0.3, because remember natural log is the log base e. So that would say e, or from Friday, about 2.7 to the negative 1.204 equals 0.3. Okay, then this last example that we're going to be looking at today is an example of using a logarithm equation in an application problem. So here this is an equation predicting the number of games sold, and we want to know in the 10th month. Well, x is 10, so you can just plug this in and do that on your calculator. I'm just going to go natural log of 9, and we get about 78.9. Well, notice that this is in thousands, so this 78.9 actually means about 78,900. If I use a couple more decimal points, 78,000 games. Okay, let me show you your homework real quick. Couple of comments I want to make on it. Okay, so the first page here is just rewriting. If it's an exponential equation, you're going to rewrite it as a logarithm. If it's a logarithm equation, you're going to write it as an exponential. So this first page, that's all you're doing. You're just practicing converting from one form to another. Okay, then on the second page, you're going to evaluate. So here, you might want